Good evening. I'm based at the Australian National University in Canberra, and I'm going to talk to you about a technology that we are developing, which is used for studying the brain. As you all know, our brain is one of the most complex organs in the human body, and it pretty much controls everything that we do in our daily lives, whether it's how we see, how we move, or how we make decisions, or how we react to a particular situation. The brain does so much of it just with the help of cells called neurons. And our brains have about 100 billion of neurons sitting inside and processing all this information. When the neurons have these connections coming out of them, and then they connect with each other with help of a network, which is the neural network. So you can imagine the brain to be like a big supercomputer where there are millions and billions of circuits made with neurons and the neural networks. Now, in real life, this is how a real neuron looks like. This is a cell, and these are the processes coming out of it. And then when they come out and they find other cells, they form a real neural network. So these are some images from my laboratory. And as you can see, the neurons are actually three-dimensional in nature. So they're just not flat like this image shows, but they have a particular structure to them. Now, when a brain gets damaged due to an injury or a disease, what happens is that these neural networks or these circuits get disrupted. And unlike other cells in the body, neurons cannot form these connections back by themselves. And currently, we don't have any drugs available to repair this damage. We don't have drugs which can guide the formation of neural networks in the brain. So people are left with all sorts of disabilities, loss of vision, loss of movement, and loss of memories, in fact. So there's an urgent need to understand how the brain works, how these connections are formed in the brain. So the idea is, if we understand how these circuits form and how they function, then we can develop the solution to the current problems, such as dementia or Parkinson's, because then we could develop treatments, cures, and alternatives of what we have available right now. So my idea is to use technology and engineering principles to find these solutions. And the technology that I'm developing at the ANU is based on the chip. And the chip is basically a nanoscale scaffold. Now, you must have heard a lot about the word nano. Nano actually comes from the Greek word which means dwarf, and it's about 1,000 times lesser than the thickness of a hair. So to give you a perspective, a DNA molecule is about 2 nanometers thick, while our hairs are about 1,000 times a nanometer. Now, what exactly the chip is, or what my scaffold is, it's actually a chip based with these features which are about 100 nanometers in diameter. So I have lots and lots of these, and once I have these, I would grow cells on top of this. I would grow brain cells on this and then study how brain cells form circuits and how they function. So the idea is these structures mimic the brain. So once they mimic the brain, you guide neural networks to form. Once you're able to guide the formation of neural networks, you then go on and understand the formation of circuits and functioning of neural circuits in the brain. To give you an idea of how neurons behave on this chip, this is a single brain cell, and as you can see, the connections coming out of this cell are actually following the nanoscale features on my chip. So in the first image you saw the neurons were growing randomly. Here the neuron is growing in a straight connection. And to have lots and lots of neurons, you can see that when the neurons grow on this chip, they actually form these circuits in straight lines because my nanostructures are arranged in a straight line. So once we have the circuit formation, we then go on to study circuit function. And how we do this is, for example, we have neurons connected in a particular order here. We have ordered circuits, and then we realize that when circuits form in an ordered way, this brain activity is synchronized. So the activity happens in all these cells together. So we have a technology where we guide neuron growth, we study circuit formation, and we study circuit function. From here, for the future, the idea is to create regenerative scaffolds. The scaffolds where if we have a damage to the brain, the circuit gets damaged, and ultimately we put in a chip which repairs this damage back to its original form, back to its original function, and hence we have a treatment. Thank you.